I made a video by writing HTML. No editor, no timeline, no drag and drop, just markup in a text file. And it rendered to a real MP4, ready to upload. The tool that did it is free, open source, and built for AI agents. Here's what we'll cover: what HyperFrames is, how it turns HTML into video frame by frame, why every render comes out identical, and how you can start today. HyperFrames is an open source framework from HeyGen. Its tagline, write HTML render video built for agents. Released March 2026, it's already passed 41,000 stars on GitHub. Apache 2.0 license, TypeScript, and the source of truth for your video is an HTML file. That file is a composition. A div declares the canvas with data attributes width, height, duration. Every timed element carries the class clip, plus data start and data duration. A GSP timeline, paused and registered on the window, drives the motion. Time is data, animation is code. The smallest composition is 7 lines of HTML. A heading, 3 seconds, 1 video. That's it. No editor, no proprietary format, just the web coerced into standing still. And the same file plays in the browser and renders to MP4 with identical frames. So how does markup become video? Headless Chrome opens the page. The engine asks for frame 90. Every animation seeks to exactly that time. Chrome's BeginFrame API paints the pixels in one atomic capture. FFmpeg encodes the frames and mixes the audio, frame by frame, 30 times a second. Why BeginFrame? Browsers are sloppy timekeepers. They paint when they feel like it, drop frames under load, drift by microseconds. Fine for user interface, catastrophic for video. 900 frames have to land on the same tick, every render on every machine. So HyperFrames stole the clock. That gives you the core guarantee. Same input, identical output every time. No wall clock, no unseeded random, no midrender network fetches. Frame 90 depends on exactly one thing, the number 90. That's why renders are resumable, why parallel workers agree, and why CI can trust the output. Any animation runtime can plug in through the frame adapter contract. GSP is the default, but Lottie, 3JS, CSS animations, and the web animations API all speak the same seek protocol. Give me a frame, I'll draw that exact moment. Determinism is the contract, not a special case. And the same HTML plays back in the browser, a web component around 4 kilobytes that boots the same runtime as the render pipeline. It scrubs, it loops, it embeds. Edit the file, refresh, see it move. Render it, upload it, the frames are identical. No parallel universes. HyperFrames is built for agents. There's a hosted MCP connector, so an iChat can create and render without installing anything. 19 skills encode the framework's rules: composition, animation, keyframes, media. And the CLI validates. Lint checks the structure. Check runs a headless browser audit for runtime errors, layout, motion, and contrast. On top of that, a catalog of over 130 installable blocks, terminal windows, code snippets, charts, captions, transitions, shader effects. Paste one in, wire the data attributes, and it's part of your timeline. Who's actually using it? tldraw generates pull request walkthrough videos with animated code diffs. HeyGen runs it across its own AI video surface. Reap renders agent first clipping and editing. OpenMAIC exports AI classrooms with one click, all listed in the adopters file on the repo. How does it compare to Remotion? Remotion asks for a React component and you do the timing math in frames. HyperFrames asks for an HTML file, markup declares when things are on screen, a timeline declares how they move in seconds. No build step, no component tree. The file you write is the video. What separates a cheap render from a premium one is the motion. The docs are explicit, nothing ever fully stops. The camera is an actor, action overlaps, overshoot lands on transforms, never on numbers. One idea per scene, the single biggest quality lever. Every movement has to mean something. And it stays fast. Draft quality renders in a fraction of the time for review, standard for delivery. Heavy blur layers and oversized images are the usual bottlenecks. The docs tell you exactly where to look when a preview stutters. To start, install the CLI, initialize a project, install the skills. Write your first composition, run the checks, render. Your first video ships in minutes, and because the source is HTML, the video lives in Git like code. HTML as the source of truth, the browser as the renderer, determinism as the contract. That's how you write video like code. Links and the full workflow are in the description below.